Welcome to question 5 of the 2009 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So we have 4 identical balls are numbered 1, 2, 3 and 4 and they are put into a box. A ball is randomly drawn from the box and it is not returned to the box. A second ball is then randomly drawn from the box. For part A, we're asked what is the probability that the first ball drawn is numbered 4 and the second ball drawn is numbered 1. So that is asking the probability that we draw a 4 first followed by a 1, which is equal to. And on the first draw we have 4 balls, with one of them being the ball that we want to draw, so there's a 1 in 4 chance that we'll get the ball numbered 4 first. And then the second time we select a ball, there's only 3 balls remaining, and there's only one of those that satisfy this question, that is a ball numbered 1. So completing that multiplication we get that there's a 1 in 12 chance, so that is the answer to part A of this question. Another way that you could answer this question is by considering some sort of sample space representation such as a grid, where as the balls are not replaced we can't get a 1 followed by a 1, we can't get a 2 followed by a 2, a 3 followed by a 3, or a 4 followed by a 4. So that leaves 12 outcomes remaining, and they are the boxes that are not shaded in here. And the only cell in this table that satisfies the requirement that the first ball drawn is a 4 and the second ball is a number 1 is this box here. So there's a 1 in 12 chance of that occurring. So from the examiner's report, nearly 80% of students got full marks for this question, and those that didn't get it correct often showed poor arithmetic in completing the question. So that is, they probably weren't very good at multiplying out these fractions. For part B, we're asked what is the probability that the sum of the numbers on the 2 balls is 5. So in this table representation that we have below, we can now work out what the sum of the balls will be. So a 1 and a 2 will give 3, 3 and 1 will give 4, and 4 and 1 will give 5. And if we continue that on, we would get 3, 5, 6. This would be 4, 5 and 7. This would be 5, 6 and 7. So now that we've set up our sample space, the probability that the sum is 5 is going to be 1, 2, 3, 4 outcomes out of 12. So therefore, the probability that the sum is equal to 5 is simply equal to 4 outcomes out of 12, which is a 1 in 3 chance. So that is the answer for part B of this question. From the examiner's report, we can see that nearly 2/3 of students got this answer correct, and students encountered similar difficulties to that experienced in 5A, so that's where their arithmetic may have been an issue, or they may have been unable to set up the sample space that was required. So for part C, it says given that the sum of the numbers of the 2 balls is 5, so that means that our sample space is reduced to 1, 2, 3, 4 outcomes in that table that we set up before. We're now being asked what is the probability that the second ball drawn is numbered 1. So the second ball being drawn is numbered 1 is this 1 outcome out of a sample space that's now been reduced to 4 outcomes, so there's a 1 in 4 chance of that occurring. We can also calculate that using our conditional probability formulas. So if we're going to do that, we'd be looking for the probability that ball number 2 is equal to 1, given that the sum is equal to 5. So for that, the intersection is simply a 1 in 12 chance over the condition, which was, as we saw before, a 4 in 12 or a 1 in 3 chance. And if you evaluate that, that's the same as 1 in 12 multiplied by 12 over 4, so we multiply by the reciprocal, which simplifies down to be a quarter. So that is the answer to part C of this question. So around 40% of students got full marks for that question, and some of the students obtained the answer from first principles. So similar to what we did with the grid, for some students they were able to obtain that correct answer of 1/4, despite sometimes having incorrect responses for 5A and or 5B, which were sort of lead up questions that you could have used to help answer this problem.